Hi all, so welcome to the today's tutorial. Today we will learn a concept called dot product. So it is quite important when it comes to the dot product in the game world. So let me show you the few examples here. So let's imagine you do want to know what is the direction you are looking and what's the direction your enemy looking. So this is just one scenario, and let's imagine what's the direction of the enemy gun and what's the direction of your gun. Is it similar? Is it different? Are you, just to apply different mechanism. If you hit your enemy from front, you will get more points. If you are hitting your enemy from the back, you will get less points. So in all these scenario, we can use dot product. So first we will see what is the dot product, how we can calculate it, and how we can use it inside the game. So these were the just few scenarios which I have told where we can use a dot product. So dot product is like so it's a scalar value. Right now when we talk about the vectors, vector is like something we have the direction and we have magnitude, right? But we talk about the dot product, the resultant will be a magnitude. And usually in game what we do when we are taking just the directional vector or a unit vector, whenever we will calculate the dot product, if the dot product is exactly equal to 1, that means we are talking about the same vector. So let me show you. Let me open that vector 2D. So this is one vector which is going from 0, 0, 0 to like 5 or like 6 comma 6, right? And I will draw one more vector which will again from this to this. So right now these two vector are exactly same except like I'm talking about the direction. So these two are exactly same, they are parallel, right? And whenever we are talking about the vectors, uh, if they are pointing to the same direction, that means if we will calculate the dot product of these two vector u and v, the result will be 1. And 1 means the vector are pointing to the same direction. And what if the vectors are pointing, like if they are making angle, like if I will overlap this, give me a second, let me move this vector from here to here and here to here. Let's imagine this is moving from here to here. So now these two vector are making 0 degree angle, and the dot product at 0 degree is 1. If I will move this vector, let's imagine here, if I will move this vector from here. So now, right now, these two vector are making 90 degree angle, and the dot product will be 0, right? So if these two vector are like from 0 to 90, that means the value will be 0 to 1. Okay, if these vectors are making more than 90 degree angle, the value will become negative. So till here, like at this position it was 1, at this it was zero point 0.5 something, now it is 0, and it will again come back to 1 but with the negative sign. So let's imagine if you have two vectors. So let's imagine if I am the right vector and the enemy is the left vector. I'm pointing the right direction, the enemy is pointing to the left direction. If I do want to see like what the angle between us, so angle is 180, right? So if I will calculate the dot product, I can easily see it is -1, and -1 means like we are looking apart. So next thing is we will see how we can calculate the dot product. So there are two formulas for the dot product. How we can calculate with the XYZ. Just multiply X with X, Y with Y, Z with Z and add them. This is the dot product which you can calculate. This is quite easy. But there is one more formula which is A. Let's imagine if I'm talking about A vector and the B vector. So it will be like AB cos theta. So this is our beloved paint. Let me try to sketch something out. Bear with me. So this is A vector dot B vector. It will be equals to magnitude of A into magnitude of B into cos theta. So let me tell you how that value was coming. So when I was talking about two vectors, when they were pointing in the same direction, let's imagine this is one vector. I am drawing one more vector but with some other color. Let's imagine this is the same vector, right? They are exactly perpendicular. So right now, if these two vectors are the unit vector means magnitude of A and B will be 1. So in that case, the cos theta will cos theta will matter, right? Because A dot B will be AB cos theta and AB is like 1, so we can easily remove it. So only cos theta is remaining. So if the angle is 0 degree, at 0 degree cos theta is equals to 1. So that is why the value was 1 when two vectors are in the same direction. So can you guess what will how we were getting the A dot B equals to 0 when the angle was 90? The reason was cos theta. If the theta is 90, the cos value is 0. You got my point? And what if two vectors are opposite in direction? So let me take some different color. So this was one and this one. So this vector is like from pointing left to right, and another vector I'm drawing and it is pointing right to left. So for these two vectors, the angle will be 180, and in 180 case the cos theta is like -1. So this was the whole mystery behind dot product. So now we will see how we can implement that inside our write-up. So let's start. We will open our vector class. So we need another vector because right now let's imagine when I am trying to do the dot product, I need one more vector, right? So and it will be a scalar value, so that is why float uh, dot product. I cannot override this sign because I was thinking to override it, but it is already reserved from C plus for C++, so we can't. So dot product, and here we need vector m vector. It will be a const. Alt enter, generate definition. It is quite simple. X into m vector dot x. Add. I will just duplicate it. Okay, this will be z. This will be z. This will be y, and this will be y. Okay, it will be written. Okay, perfect. Okay, so let's test if this thing is working out. So when we are calculating the dot product, it is not important that these vectors are normalized. So if you do want to, use that concept for one, like if two vectors are pointing the same direction, those vectors have to be, the unit vector. So in the game mode, let me have two vectors which are pointing to the same direction. Let's imagine this is one vector. So clearly the xy's are equal. That means it will make 45 degree with x and y. And let me have one more vector, vector 2, and this will be like 500 comma 0 comma 0. That means it's an x-axis, right? So these two we are already aware of. So I will draw these two. Draw vector. Give me a second. Draw vector. Okay, some vector 2. Draw vector. Okay, get world. Same thing, get world. Okay. Next, we do want to have our dot product. So dot product of vector is some vector comma dot product, and for this the value will be some vector 2. So let me check if it is working or not. Okay, Yes, so let's try. Let me compile. Let's play. So you can see these two vectors. Uh, so the angle between these two is, it is less than 90 degree. That means the value should be like between 0 to 1. So the product, you can see the dot product is way more, right? The reason being we haven't normalized them. So what we will do, we will normalize them. So some vector dot, give me a second. Let's normalize them here. Some vector dot normalized vector. And for this too, we will get the normalized vector, get normalized vector. So let's do the same, compile. Let me start the program. It is done. Compile. And right now the dot product is 0.7, and we can see it, the angle is like 45 degree. Okay, this is perfect. So let's imagine if what if we are taking the same vector. So if we are taking the same vector, the value will be, let's have the same vector. So in our case, now in this case, the value should become 1 because we are using the same vector. So let me compile and let's play. Now you can see the dot product is 1. And what if it is pointing to the opposite direction? So what I will do, I will uh, change upper to like minus 500, and we will keep y-axis to 0. So in that case, can you guess the answer? I'm compiling the meantime. So let's test, and the value is 1. Uh, and the value should be minus 1 if I'm not wrong. So let's check if we have done something wrong. Okay, when we are calculating the dot product, we are multiplying the value, yes. Okay, that was my mistake because I have written some vector here and some vector here, so it will be some vector 2. It gave me goosebumps for a second, so let me compile it again. Okay, let's play. And now you can see it is minus 1. So now you know the relevance, like how we can check the dot product and why it is very relevant in terms of game. So this was it for today. Thank you and have a nice day. If you are liking this series, do subscribe, and you can also support me on Patreon. Thank you and have a nice day.